So guys, it turns out that not all positions are created equal. And it turns out that some positions are going to have more effect on acidity than others. In fact, the meta position is going to have a much lesser effect on acidity than the ortho and para positions. Okay? Meaning that whatever type of group is on there, it just matters less if it's on the meta, and it matters more if it's on an ortho or para. Why is that? Think about the resonance structures that occur when you make a phenoxide. Remember that I told you guys that where would that negative charge resonate to? It would resonate to the top, to the side, and to the side. Notice, what are those positions called respective to the O? Those are the ortho-para positions, right? So that means the negative charge will rest directly on ortho-para positions, and it will never rest on a meta position, okay? So with that logic, what that means is that we know that a donator is going to make it less acidic because it's going to destabilize the negative, and we know that a withdrawing group is going to make it more acidic, okay? But if those same exact groups are in the meta position, so these are meta and these are ortho, right? I'm looking at orthos versus meta. If I have a donating group in the meta position, it is going to be a little less acidic, but only slightly less acidic than normal. Why? Because this donating effect doesn't really matter that much. Because it's on the meta position, the negative charge never goes there. Same thing goes with a withdrawing group. A withdrawing group, you'd think this is great, it's going to make it really acidic, but it's only slightly more acidic if you rest on the meta position. Why? Because once again, the meta position doesn't really matter, right? Because the negative charge never actually sits on it, okay? So in terms of acidity, that brings us to the following acronym, okay? So if you're looking for an acidic phenol, what you're going to be looking for is a WOP, okay? And what a WOP stands for is a withdrawing group in the ortho and para positions, okay? So you don't care about the meta positions. The meta positions aren't helpful for us. We're looking mostly at those having withdrawing groups in the ortho and para positions, okay? So that being said, why don't we take a stab at this question and tell me which one you think is going to be the most acidic phenol.